section is 6.5. We are solving square roots. Okay, so from previous two section instructions, we got familiar to how to simplify radical expressions and whatnot. And I only have 4 examples to cover today, okay? And first one, number 1, solve. If you simply have x to the power of 2/3 equals to 9, then with the variable x and the directions as solved, then consequently all we have to do is we find the value for x, right? Here, notice the variable x has exponent 2/3, right? Then the operation or manipulation that we have to do mathematically is we get rid of the exponent that goes with the variable x so that we can isolate x for the value only. Then it's the same mathematical idea. So whenever, it doesn't matter what kind of equation that you are given to solve, and then it's just all same principle, right? Okay, so then if we have x raised to power of 2/3, and then if this is 9, then what we can do to both sides is I will raise both sides by rational exponent that is reciprocal of the fraction. So x has 2/3 as the exponent, and what I need is 3/2 as the mathematical manipulation as exponent, but what I have to do is I do both sides, right? Then the next step, we already saw the power rule of the exponent rule, so that left-hand side will be x raised to, now we are supposed to multiply this, and then this is consequently x to the power of 1 is just x, and then this is the same as 9 raised to the power of 3/2. And then for rational exponents, this means the denominator of the exponents makes the index of the radical. So then this is square root of 9 raised to power of 3. And then inside of the parentheses, square root of 9 is 3 raised to power of 3 is 27. Then x is 27. And then if you plug this value that we just found back in the equation, and it should be equal to 9, right? Okay, easy. All right. So then let's move on to number 2. Then if we have square root or radical equation to solve with a lot of other terms all combined, then the principle is still the same. It's just our goal is isolate the variable, and we can take all the unnecessary terms that is attached to that variable x, in mathematical order. So order of operation, okay? So let's see, 2 parentheses, x plus 5 parentheses is raised to power of 3/4, and then minus 3 is equal to 13. Then first step, we have to verify where the variable x for us to solve. Right here. Then now I recognize which terms to get rid of from the side, right? So now we are getting rid of any unnecessary terms from the side and which are further from the variable first. So now I recognize -3 in my left-hand side. In order to transpose a term to the opposite side, and then I have to do addition, right? So then next step, it's gonna be 2x plus 5, everything copy down the same. And then the other side will make 16. Then the next term that I have to transpose the other side is the multiplying 2. Then how do I get rid of multiplying 2? Dividing. So if I divide both sides, then parenthesis x plus 5 raised to power of 3/4 is half of 16. It's going to be 8. Then now, x is still inside of the parenthesis with plus 5. And the next thing that we have to transpose or eliminate is the exponent. And we just did this, but there's some teaching in is we raise both sides by the rational exponents of the reciprocal, right? So I'll be right back. I pretend nothing happened. Okay, then I will raise both sides by what? 4/3, right? Then now I already showed the step what happens in power rule of exponent, and we'll get rid of the original exponent 3/4, and then it's x plus 5. And then this is 8 raised to power of 4/3, right? And then this is x plus 5. And then this is also the denominator is 3. So cube root of 8 and raised to power of 4 is, cube root of 8 is 2. 2 to the power of 4, fourth power is 16, right? Then we have x plus 5 is 16. And then I will subtract 5 from both sides. And finally, I get to have 11, right? Then the way that I check my solution is correct or not is we plug this 11 back in to see if that equation is still mathematically makes sense, and it should be. All right, so far any question? Okay, all right, then next one. And one of the practice problem was talking about the astronomical unit, and with the period, and so I think it's just simply plug the number in, right? Okay, I will just cover it quickly. And they were asking the mercury, right? Then I just copy the numbers here. So with the formula given already in the context of the problem, and the period of mercury is 0.24. So it was supposed to be 24 is equal to the 8u raised to power of 3/2. Then we're supposed to get the value for d, right? Then in this case, we have to raise both sides by 2/3, right? Then use your calculator. You typed 0.24, and just in case if you guys haven't used it for, but there's key looks like this, is upper arrow, then that's raised, right? That's raised to the power, right? So then 0.24 raised to power of 2 divided by 3. But in this case, what you have to be really careful is if you don't use parentheses, it's gonna malfunction because the calculator will indicate this one was raised to power of 2 first, and then whatever the powered number will be divided by 3. So we have to make sure that we have to put the parentheses for the rational exponent, okay? Then this will give you 0.386195 ... right? Then approximately, I think it was saying rounded to the 100th, so it's about approximately 0.39 AU. Okay, then one more example, number 4, it's last one. Okay, then if you have square root, one square root is a part of your equation for solving, then it's obvious you just technically square both sides so that you can get rid of the square roots, right? But if you have 2 square roots in the equation, right, then we strategically separate the square root in both sides so that we get rid of the square root at the same time, right? Okay, so if you have this equation, square root of 4x minus 7 minus square root of 2x is 1, right? Then we will separate square roots on both sides. So that means I will transpose the second square root term to the other side, and then it's gonna look like square root of 4x minus 7, and then it's positive square root of 2x plus 1. Then I will do square both sides, right? Then the left side is clean cut, and then it's gonna get rid of the square root, and it will have 4x minus 7 free. I haven't seen that commercial for a while, the sit and sleep commercial, the crazy guy like shows up, and then he always just says like matrix and then whatever, it's just free. Have you ever seen that commercial? Yeah, exactly. Like your metric something blah 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 blah, or your metric is free. Yeah, but I think that commercial was so long. Like it was like always. Like I think I started watching the commercial since when I came to America, like first time. But recently, I just don't see it. Do you guys still see that commercial? I don't know. I don't know why I thought about that. But anyway, okay. Then the square, the right side, is a little bit annoying, but we will do step by step. Here, the common misconception that I keep seeing over and over again is when you raise the power of 2, the square, binomial, and instantly, a lot of students just think, just square up first term and square up second term, but it's not. Always be careful, right? Then they will do right? Then you will FOIL. So FOIL, right? So then first and first, we'll get rid of square root. It's gonna be just 2x. It's not gonna be 4x squared because they were the square root term. And the outer term will be square root of 2x. And then the inner term will be square root of 2x. And then the last term and last term will be 1, right? Then, since we are multiplying identical term twice, this is gonna make pattern and rule, so it's gonna happen all the time. You will always have this identical midterm, and then that being said, once you are done combining like terms, and then it's gonna be always the term twice. So this is 2x plus twice of radical 2x plus 1. So if you notice this pattern, happens all the time. You don't have to go through rewriting identical terms twice and then do the 4 times of multiplication. And you can just recognize this will end up being square of the first term and square of last term, square of first term and square of last term, and then the twice of the midterm. Twice of the first term times and the last term. And then it's gonna save a lot of time for the steps, right? But it's totally fine. If you guys just don't want to risk or making any mistakes, and then totally fine that you go the FOIL. But anyway, so in that case, now, oh, this was 4x minus 7, this was 4x minus 7, then at least I can simplify by combining like terms, right? So now I notice 2x and plus 1 can be combined with the terms in from the other side. So it's gonna be minus 2x minus 1 minus 2x minus 1. Then here, 4x take away 2x is 2x. Negative 7, negative 1 is negative 8. And then it's gone from there. And it's twice of square root of 2x right here. Then now, probably we need to square both sides again. But before I square both sides, I want to make it simplified. And then divide both sides by this. It's the square root of 2x. And then the half of 2x minus 8 will be x minus 4. Then I will raise both sides to square. Then here, now I get 2x out. Then again, I have binomial squared again. So now let's apply the pattern that we saw earlier here, right? Then this is for sure the square of first term, what? X squared. Square of the last term is square of 4 or square of negative 4, it doesn't matter. Square, it's gonna make positive anyway, it's gonna be 16. Then if I multiply first term and last term, it's 4x, it's a negative 4x, but it's gonna be what? Twice. So twice of negative 4x is 8x. Done. If you want to double check and then you can rewrite twice and then FOIL, but it's still gonna be same, right? Then now I can transpose 2x from the right hand side, minus 2x here. Then it will change the color. X squared minus 10x plus 16 is 0. Then now I can factor this x and x. And 2 and 8 and minus will make negative 10 and positive 16. So it's good. Then from there, when I solve for x, we use zero product rule. So the first parenthesis, x minus 2 might have been 0, or x minus 8 might have been 0. From there, I can assume x could be 2 or 8. Then here, it's not done. You always have to remember, since the manipulation mathematically, the steps that we manipulated mathematically involved squaring a lot. Then always remember the squaring or square root involved with extra cases, because whether it's positive or negative, once we square that, and it's gonna be just the same value, it's always gonna be positive. So that means we have to consider there's some extra product, extra result that we created while we were manipulating these original equations, right? Then the way to check it is we have to plug both to see if they're all working or if there's some value that's not working. Then if we find some values not working, then that's gonna be called extraneous solution, okay? Then going back to original equation, then now we're checking. So check 2, if x is 2, then square root, and 4 times 2 is 8 minus 7 minus square root, and then 2, there is a 4, and then this is square root of 1 is 1 minus square root of 4 is 2 is negative 1, not 1. So 2 for x is not true. So then x cannot be 2, and then this is what? Extraneous solution. And then let's quickly check if 8 works. So then square root, check 2, square root of 8 is 32, take away 7 minus 16 is radical of 25 minus radical 16. Yeah, it's a 5, take away 4. Yeah, we're checking 8. So 8 is okay. So then we can only adapt the value for x, not 2, but 8 only. So 8. So this is extraneous. This is extraneous, and then this is correct answer. This is correct. Answer. This is extraneous. So you have to remember when you solve square root equation, and you always have to check both of your solutions if they are working. I mean, sometimes both work, but sometimes it's not gonna work. Any question?